Okay, guys, so last part of the review video. In part two, we went over questions 5 through 10, I believe, or maybe 6 through 10. Okay, so this is where we left off. Now let's get started on question 11. So, which of the following transformations does not preserve congruence? And remember, congruence means staying the same. Let me think. It's staying the same size, pretty much. Okay, when you're dealing with shapes, right? So this first one, x plus 2 and y minus 5. So if I start at the middle, x plus 2, remember, if you see x plus, you're moving to the right, okay? I move to the right 2, and y minus means I'll move down. In this case, I'll move back 5. Now, am I the same size as I was when I started over here? Yes, so I preserve congruence, okay? And we're looking for what doesn't preserve congruence, so that's out of the question. Now, 2x and 2y. 2x and 2y is telling me to get bigger by 2 times, right? So if I'm right here and I grow let's say 2 times. Just pretend I just grew 2 times my size, right? So my height right here is originally where I'm at, okay? Here's my height. Now I'm going to, okay, do you see that I got bigger? So I'm not the same size anymore. I didn't preserve my congruence, right? So this is a possibility. Let's circle that. Now, x, y to negative x and y, well, that looks like what we did right here, and that would just tell me to flip, right? Now, I'm still the same size, right? If I flip, okay, so that's not it. And then negative y, x, I would have to flip upside down, and I don't want to break a neck right now, so I'm not going to do that, okay? But I would still be the same size, right? So my congruence would be preserved. So that means that only in a dilation does your congruence not get preserved, okay? Only when you get dilated, when you get bigger or smaller by that scale factor, your congruence will not be the same, okay, as before and after, right? So question 12, this gave a little bit of trouble to some of y'all, but let's break it down. A park has a rectangular sandbox and a rectangular soccer field. Okay, so we know that we're dealing with 2 of the same shapes. And the soccer field is 2.5 times larger than the sandbox. So we're going to draw a rectangle, okay? Okay. Now this is going to be my sandbox. It doesn't tell us how long the sides are for the sandbox, so why don't we just make up numbers, okay? Let's say that this side is 2 and this side is 1. Now, since it's a rectangle, I know that parallel sides will be equal to each other, so these will be 2 and this will be 1, okay? Now, the soccer field, will be over here, is Now the soccer field, it says it's 2.5 times larger than the sandbox. Okay, well then if that's true, we can just take our side lengths from the sandbox and multiply them by 2.5 to find the side lengths over here. So let's go ahead and do that. Let's do 2 times 2.5. 2 times 2.5 in the calculator will get you 5. And then over here, we're going to take 1, this side length and this side length, because they're corresponding sides, right? We're going to do 1 times 2.5. Excuse me. So 1 times 2.5 will equal 2.5. And again, since it's a rectangle, the parallel sides, the opposite sides will be equivalent to each other. So 5 up here will be 5 down here. 2.5 over here will be 2.5. So now it's asking us, how many times larger is the perimeter of the soccer field? Let's find out, okay? To know that, I need to know what the perimeter of the sandbox was, okay? So let's label our perimeter as P, okay? Again, perimeter, how do you solve perimeter? You add up all the outside. So 2 plus 2 plus 1 plus 1 would get you 6. And area, okay, area equals length times width. Our length is 2 times our width of 1. 2 times 1 is 2. Again, area equals length times width. Length times width. 2 times 1 is 2. Okay? So our area equals 2. What about over here? Let's label this one P prime and A prime. Okay? Because look at the question. If it's telling you that the rectangular soccer field is 2.5 times larger than the sandbox, then 2.5 is our scale factor. Okay, 2.5 would be our scale factor then. All right. So if this is our original, then this is our new. That's why I'm putting the prime mark. Okay. So the P prime stands for perimeter prime. Okay. Again, perimeter is adding up all the outside. 5 plus 5 will get you 10. 2 plus 2.5 will get you 12.5, and another 2.5 will get you 15. Okay. Okay. Again, area equals length times width. So L times W. And length times width would be 5 times 2.5. 2.5. And 5 times 2.5 would get you, let's see, 5 times 2.5 will get you 12.5. Okay? So your area, length times width, 5 times 2.5 would get you 12.5. Okay? So our area will be 12.5. Now, the question asks, how many times larger is the new perimeter of the perimeter of the soccer field? Okay, so let's do that over here. I can find that out by doing new. Let's do new divided by original. So I'm going to take my new perimeter over here, excuse me. My new perimeter is the one with the prime mark, so 15 over my original perimeter, which is 6, okay, because that was the sandbox perimeter. Now, if I put 15 over 6 into a calculator, it will simplify it down into 2.5. So 2.5. Now, what do you notice about this number, 2.5, and the scale factor? They are the exact same. So, in a dilation, after you dilate a figure by the scale factor, okay, the perimeter change will be equivalent to or equal to whatever the number of the scale factor was, okay? So in this case, our scale factor was 2.5, and how many times larger was the perimeter of the soccer field? 2.5 times larger. Now we're going to do the same thing to find the area change from the soccer field, from the sandbox to the soccer field. So we're going to do new divided by old. Our new area right here, A prime, is 12.5 divided by our old area, which is 2. Now, if I put 12.5 divided by 2 into the calculator, I should get 6.25. Okay, so that means 6.25 would be our, how many times larger the area of the soccer field is. So you can do this, or you can take your scale factor. So our scale factor is 2.5, okay? If our scale factor is 2.5, all you would have to do to find the area change is square it, which means 2.5 squared is 2.5 times 2.5, which will equal 6.25. So, what I'm trying to show y'all by that is, again, it's asking how many times larger is the area of the soccer field. You can do the new area divided by the old area, and you would find it that way. Or you can just take your scale factor and square it, and it will equal the area change, right? Because look, 6.25 is, whenever you square 2.5, you're going to get 6.25, which is the same as what we got up here, okay? So let's take a look at question 13. Figure JKLM is similar to figure PQRS. Which proportion is true for this relationship? Okay, so look at these two shapes, right? They are the same, except that this one is a little bit kind of tumbled or rotated almost. So let's go ahead and draw a new shape. Okay, so we're going to draw the same one as this, right? These are the same shapes. Now, how do I know where to put these new points, P, Q, R, S, on this one? Well, what I want y'all to start doing is numbering off the points. So J would be 1, K is 2, L is 3, and M is 4. So the corresponding points are going to have the same number. So the first one is J. So the first one over here would be P, then Q, then R, then S. So now, where is J? J is number 1. We go to number 1 over here, and that's P. So wherever J is on this shape would be P on the other. What about Q? It's going to match up with K. K is right here. Q is going to go right here. And then R and S. Okay? So now let's see. Which proportion is true for this relationship? QR over QP. So this side length over this side length is proportional to JK over LM. Is that true? No, it's not, because look, QR is saying that QR is proportional to JK. This side length cannot be proportional to this side length. They're going to be two different things. That's incorrect. QR, which is right here, is equivalent to RS, all right, or proportional to RS. But, or we can see it as QR is proportional to KL. Yes, that's good so far, because this side and this side match up, right? But do RS, which is this bottom portion, match up with JK right here? No, it doesn't, okay? So, B is incorrect. Now, as you can see, QR right here is equivalent to is QR over MJ. QR over MJ is proportional to RS over LM. Is that true? So look at the first thing that we wrote. QR over MJ. Now this QR is on the right side of this shape, but MJ right here is on the left, okay? So those aren't corresponding sides. That means they are not proportional. So that obviously leaves us with D, but let's double check. So QR, which is this right side, over KL, which is this right side. Okay, so far so good. They're corresponding sides, so far so good. Equals PS, which is this side, over JM, which is right here. So yes, we're good. They were proportional. All right, and last question. In the diagram, a person who is 6 feet tall is standing on the ground 3 feet away from point P. A line segment drawn from the top corner of the building to point P creates two similar triangles. What is H? The height of the building. So let's go ahead and set up our proportions. Now we have two different things. We have a man and we have a building. So let's write man right here and set up our proportion and set it equal to the building, okay? Because the triangles that they would create are similar. So up top, let's put the height of the man, okay? Because the man is 6 feet tall right here. And how far away is he from point P? He is 3 feet. So we're going to put 3 under that. Now on the other side, since we put the height of the man on top, the numerator for the building has to be the height of the building. We don't know that. So that's going to be H, okay? And below 3 is how far away the man is from the point. How far away is the building? This building is 18 feet away. So now to solve for H, I'm going to cross multiply and divide. So we got 6 times 18 equals 3H, right? Because 3 times H will make 3H. Now, I'm going to do 6 times 18, which turns into 108 equals 3H. To get H by itself, to solve for the height, I would divide by 3. Okay, so these cancel out. 108 divided by 3 equals 36. Okay, so that is how you set up a proportion and solve for the missing side or length. So good luck on your test tomorrow. Message me, email me if you have any questions, and I can help you out. Okay, good luck, guys.